All right, guys. So we're going to go ahead and work through lesson 5.7. This will be the last lesson that we cover in chapter 5. It's called the Binomial Theorem. Our learning target is I can use the Binomial Theorem to expand binomials of a higher multiplicity. So let's go ahead and kind of skip real quick and we'll come back to it. Let's skip, kind of look at the next page. And these are kind of the types of examples we're going to be looking at right here. So kind of trying to take like x minus 5 to the fourth power, 3x plus 5 to the third power. So we're going to learn a way to basically avoid, and I wouldn't write this, but to avoid having to kind of take like x minus 5 times x minus 5 times x minus 5 times x minus 5. Now, anybody who's tried like the bonus questions on, what lesson is it? Where you have to like multiply the roots out. One of our lessons knows that, you could do that right there, but it would be kind of a bear of an answer, right? So we're going to basically learn a shortcut to not have to just multiply each binomial individually, okay? So anyways, that's kind of the what we're doing. Here's how it works, okay? So one part of our shortcut, one part of the binomial theorem is Pascal's triangle, okay? So you might have heard of that before, you probably haven't, but basically it's just this pattern. So I'm gonna write the first few first few rows, and you kind of see if you're picking up what I'm throwing down, and you could do the next few. So let me give you, so we would have kind of row 0 up top, and that's just 1. Okay, that's easy enough. Row 1 below that is a 1 and a 1. Row 3 is 1 and then 2 and then 1. So I think the ones at the end are pretty obvious. Might be thinking where'd the 2 come from, and let's see if row 4, you can see the pattern. So start with a 1. In between the 1 and the 2 would be a 3. In between the 2 and the 1 would be a 3, and then a 1 out at the end. So I've taken you to row 4. See if you and your partner can kind of figure out, maybe in the next few seconds, how to get to row 7. So give me a row 5, a row 6, a row 7. If you don't see it, just wait and we'll copy it together. So where are we getting the non-1 numbers, right? That would be the question. All right, so the answer to the question, where are the non-1 numbers coming from? It's just the sum of the 2 that it's in between, okay? Bless you. So you always start with a 1. To know what comes next in row 5, you're thinking 1 plus 3. So 4, if you had 4 there, you got it. And then 6 in the middle, 4, and then 1. Okay, row 6 would be 1, 5, 10, 10, 5, 1. And then row 7 would be 1, 6, 15, 20, 15, 6, and 1. Okay, so the idea is you could kind of produce that triangle on your own, right? Because it's simple to produce, but you got to kind of know the pattern, right? And we'll figure out how and why we use that in just a minute, okay? But for now, we'll just have it on our notes. Yes. Oh, it does. I'm sorry. Yeah. So we only got to row 6. Is that right? 1, 2, 3. Yeah, we only got to row 6. Thank you, Ava. I'm sorry about that. Yeah, we don't just skip row 2. So I'm sorry about that. And thank you for clearing that up. Yeah. So we got to row 6, not row 7. Anyways, yeah, we have row 2, row 3, row 4, row 5, and row 6. All right. So everybody kind of good so far? Everybody got that down at least? Okay. All right, so then it says you can expand any binomial by using the distributive property. We just talked about that. That would be the non-shortcut way. But here's kind of, it shows you the first few, if we expanded a binomial a plus b to several powers, it kind of shows some examples. So that's just something you can reference back to. Here are some observations, though, and then we'll just do a few, and I think that's where you'll really get it. So our powers of A. So what's A? A is just kind of our lead term, right? So powers of A, those, let's see if we can look at that bottom row and see anything about it, right? Powers of A go from 4, 3, 2, 1 to 0, right? So we would say they're descending would be the word there. Descending. Start high and low. So your lead term starts high, ends low. Powers of B, right? So powers of B, B is my second term. Okay, so if we look at those in the row above, we have, B to the 0, B to the 1, 2, 3, 4. So the word there would be ascending. Those start low and high. The next thing should say sum of exponents instead of sum of exponents. So let's think about our exponents of our variables. Okay, what's the sum, right? So in our first term we have a to the fourth, and that's it, right? So that sum of exponents would be 4. Next term we have a cubed b to the first, so that sum would be 4, right? And then you have 2 and 2, so forth. So they always add up to that highest power. So maybe just write something like that. Always add to highest power. And then how is Pascal's triangle coming into play? Well, if you look at our coefficients, 1, 4, 6, 4, 1, that is a row of Pascal's triangle. Which row is it? That's row 4, right? So those are basically your coefficients. So that's where we look at Pascal's triangle. Okay, so all that put together leads to this shortcut, okay? And it's not going to seem like maybe much of a shortcut at first, but once you kind of get the gist of it, I think you can work through these relatively quickly, okay? So in the diagram from the textbook, they show us a to the 0 down to a to the 4. So if we skip row 5, what would a plus b to the 6 look like? All right. So if we're going to do that, we're going to need, one thing we're going to need is row 6 from Pascal's triangle, right? So you can just reference that, and I'll just write it down so you don't have to flip back and forth. But that row would be, your 1, 6, 15, 20, 15, 6, and 1. So that tells you right there that basically if you count those up, that's 7 terms. This thing's going to have 7 terms, okay? So also I'm going to say this for anybody who looks at the filled out notes on Google Classroom. The way, so I attached Miss Nash's notes. That's like one of those tongue twisters. But she shows her work quite a bit differently than I do. So if you don't like the way I show it, maybe look at the filled out notes. And I'll just we're doing the same thing, but it's just laid out differently. But keep that in mind if you look at those. Anyways, here's how we do it, okay? So our first term is going to be, it's always, you use that coefficient. So 1, and then you have a to some power times b to some power, right? So you start with a high, so a's to the 6th, and then b to the 0, okay? So we'll simplify kind of at the end. And then you have, our next term would be 6, and then a and b to the something, right? So you have a to the 5th. Remember, that's descending, and then b to the 1st is ascending. Next term would be 15. Just follow your pattern at that point. A to the 4, B to the 2. Then you have 20. A to the 3, B to the 3. 15. Next term is plus 15. A to the 2, B to the 4. And then 6. A to the 1, B to the 5. And finally, 1. A to the 0, B to the 6. So this gets a little tedious. But then as far as simplifying, I'm not going to rewrite the whole thing because most of the terms are simplified. But let's just make a note underneath which ones would kind of be simplified if we were typing this in as an answer, say, on Math Excel. So like our first term, well, let me just kind of highlight the terms that we could simplify. This one we could, anytime you have a 1 coefficient or something to the power of 0, you know, this we could kind of clean up a little bit. The ones in the middle are pretty clean. We could clean up that. And then that. So as far as kind of writing them, how you would type them, like our first term would just be a to the 6. That's it. You have 1 times a to the 6. Next term would be fine, but you probably just usually don't type b to the 1st, so you'd usually type that in as 6a to the 5th b. The second to last term, you'd probably type that in as plus 6a b to the 5th. And then the last term, you would definitely want to simplify that. That would just be b to the 6th. That might have looked neater if I just brought down everything, but the ones in the middle were pretty much simplified already. So, all right, so that's kind of a generic way to start it. Example 2 are more like what your test questions are going to look like. Okay, so let's start with B, which is a little bit easier than A. What might make A just a little bit tougher? Actually, we could start with A. That's fine. Let's just start with A. Okay, let's start with A. All right, so let's get our row of coefficients. That'd be row 4 from Pascal's triangle, which is, see if you can at least find it. See if you can find how it starts. What's row 4 start like? All right, so it should have been 1, 4, 6, that row right there. So 1, 4, 6, 4, 1. There's always one more term than the power, right? So that's 5 coefficients, 5 terms, right? All these patterns, right? You start to notice. In this one, we don't have an A and a B, so we'll say what those are, right? So our A term in this case is going to be X, and our B term is going to be, this is, you just call that -5. We'll call B -5. So there's not like a separate formula for A minus B squared. Okay, we just plug it in as -5. All right, so let's go term by term and see what we have at the end. We will clean this one all up at the end. Okay, so first term, lead coefficient is 1. Then our A is X, so we have X to the, what are we going to start with there for X? Is it going to be to the 4th or to the 0? Anybody remember or anybody know? It's going to be to the 4th, right? You always start high with the lead term, okay? And then your other one's going to be to the 0. So times -5 to the 0. So that's term 1. Term 2 is going to be 4 times X to the 3rd times -5 to the 1. Next term is going to be 6 times X to the 2nd times -5 to the 2nd. I'm going to pause there because I've written quite a bit. Does anybody have any questions or not seeing the patterns or anything? Then we'll worry about simplifying here in a minute. Okay. So I'm going to write up the last two terms without talking through them, give you a chance to do that and then check, or you can just copy what I'm writing if you don't see it yet. All right, so last two should have been 4x to the 1, negative 5 to the 3, and 1x to the 0, negative 5 to the 4. Okay, everybody with me? I'm just kind of setting it up. All right, now we kind of clean every term up, okay? So the only work you really should have to do is for the coefficients. So let's go ahead and copy down the easy part first. Let's just do the kind of the all the variables, okay? Or just the, yeah, just x to the whatever power, right? So my first term is going to end in x to the 4th. My second term is going to end in x to the 3rd. Then I'll have an x squared term, an x term, and then x to the 0 is just 1, okay? So now we'll go to the calculator as far as what are my coefficients, and then the constant at the end, okay? So that was the easy part. This is where we got to be a little more precise. You just go term by term, right? So the first term is pretty easy. You can type it in if you forget, but basically that coefficient is just 1 times 1. Anything to the power of 0 is 1. Like I say, though, if you forget, you can always just type it in. 1 times negative 5 to the 0 is just 1, right? So that term will stay as is. It's simplified. Next term, my coefficient is going to be 4 times negative 5 to the 1st. You can type that in as 4 times negative 5 or 4 times negative 5 to the 1st, either way. But that's minus 20. So my next term overall is minus 20 x to the 3rd. Then we keep going. So my next coefficient for x squared is going to be whatever 6 times negative 5 squared is. Now you might notice I'm typing that in parentheses. Those are important, right? Because if you don't, you're going to get negative 150, right? It should be 150. So you got to be careful there. So my next coefficient is plus 150. So then we'll work on our coefficient for x, which is going to be 4 times negative 5 to the 3rd. 4 parentheses negative 5 to the 3rd. So that's minus 500. And then my last term is going to be basically 1 times negative 5 to the 4th. So really just negative 5 to the 4th. Parentheses, negative 5 is my base. Caret key 4. That's plus 625. So there's another pattern we haven't talked about yet, because this is b is negative in this case. What's the obvious observation here with the signs? What's happening with the signs of each term? Yeah, they're alternating. That's right. Right. Starts positive, then negative, positive, right, and so on and so forth. So that's what happens anytime b is negative. Okay. Any questions before we move on? All right. So let's see if we can go a little bit quicker. This is a shortcut after all. All right, so looking at example B, our power is 3 here, so we want row 3. It should have 4 coefficients in it. Anybody have that row for me? What are my numbers? Bailey? 1, 3, 3, 1. That's right. Man, if a 1, 3, 1 works in basketball, I think how good a 1, 3, 3, 1 would work. It'd be unstoppable. I don't know if it's legal, though. All right. So anyways, then we have A is 3x and B is 5. So all of our terms are going to be positive here, but our coefficients might be a little bit tougher because we have a couple numbers going on. All right. So term 1 would be 1 times 3x to the what? Say it if you know it. Third. Good. It was either going to be third or 0. Then times 5 to the 0. Next term is going to be 3 times 3x to the 2 times 5 to the 1. Then we have 3 times 3x to the 1 times 5 to the 2. And finally, 1 times 3x to the 0. Honestly, you could just leave that one off if you wanted, times 5 to the 3rd. All right, so when we simplify, let's go ahead and do the easy part first, right? Just our variable to its given power. Okay, so first term is going to end in x to the 3rd. Next term is going to end in x to the 2nd, x to the 1st, and our last term is going to be called a constant, right? So that now we figure out our coefficients. All right, so first term, my coefficient is going to be 1 times 1 times 3 to the 3rd, right? I have to take 3 to the 3rd power here. So that's 27. So that's my lead coefficient, 27 x to the 3rd, okay? My next coefficient is going to be the product of 3 times 3 squared times 5 to the 1st, or just 5. So that's 135. So plus 135. You really don't need the parentheses here because we don't have that negative to worry about. So you could type these in a little quicker as well. So my next coefficient is 3 times 5 squared. So 225. And then my last term, which is going to be a constant, is just going to be 5 to the 3rd power, which is 625. Sorry, 125. Just kidding. 5 to the 4th power is 625. So let's try 125. So since we're just taking it to the 3rd power. And that's it. And you might be thinking, man, that'd be quicker if I just multiplied it out. There's nothing that would prevent you from doing that on the test. This is just kind of a shortcut, right? If you had to take something like to the 8th power, this would be the only feasible way to do it. Anyways, just do as much as you can on C. I will show it in just a minute. Feel free to work with each other. Try to do it without just copying it off the notes. And that way you can see if you have any questions. But I'll work through it pretty quick when the timer goes off. And that will be our last example. All right, guys, so what we'll do here in a second is I will just write up the answer. If you feel like you got it at that point, you don't need any further explanation, then you can go on to the assignment. I would definitely check the answer first. And if not, I'll work it out kind of and show you the gory details, okay? All right, so the answer, and you know you've got it if you've got the answer, is, let's see, it's going to be 6 terms, right? So it starts with 32x to the 5th. Thank you, sir. Next term is minus 240x to the 4y. The next term is plus 720x cubed y squared. Then you have minus 1080x squared y cubed. And plus 810x y to the 4th. And finally, minus 243y to the 5th. If you got all of those right, or you can tell where you made a simple mistake, I'd say you're probably good to go on to the homework. Since I'm making a video here, I'll go ahead and work it out. So if you are just kind of lost, I'd recommend watching another, okay? And asking questions if you have any, okay? But if you're tuning me out working on homework, that's fine. All right, for anybody watching along here, we're raising this to the 5th power, so we want row 5 as far as our coefficients go. So row 5 of Pascal's triangle is 1, 5, 10, 10, 5, 1. And then we just follow our patterns from there, right? So in this case, we have A is 2x, B is 3y, and then we just get to it. All right, so first term is going to be 1, and then we have times 2x to the 5th times 1. Really, we can just leave that next term off. Then we'll have 5 times 2x to the 4th times 3y to the 1st. Next term is going to be 10 times 2x to the 3rd times 3y to the 2nd. See you, buddy. Next term is 10 times 2x squared times, sorry, I wrote that last term weird. The exponent goes on the outside. I just realized I wrote that up weird. 2x to the 2nd, and then 3y to the 3rd. Then we have 5 times 2x times 3y to the 4th. And I'm about out of space. And then our last term would be 1 plus 2x to the 0, which we can just leave off, times 3y to the 5th. So that's how you plug it in as far as getting each coefficient. First coefficient is just going to be 2 to the 5th. 2 to the 5th is 32. Next coefficient is going to be 5 times, yes. Oh, is it negative? I'm sorry, I didn't even notice that. I'm just looking at the notes, didn't even notice. Yeah. So, yes, the 3y should be negative. Thank you. B is negative 3y. That's where our minus signs come in. Ava, you're saving me today. So yeah, those B was negative 3y in this case. Coefficient of the next term would be 5 times 2 to the 4th. And then times negative 3y, or sorry, times negative 3. So that's where we get our minus 240. Then our next coefficient would be 10 times 2 cubed times negative 3 squared. This is where parentheses can kind of come into play. That's going to be a positive number, unless we type it in wrong. So that's plus 720, right? And then we just kind of go from there. Next coefficient, 10 times 2 squared times negative 3 to the third. Is going to be minus 1080, and so on. So if you guys need any more help than that, I didn't show every term, but we're about out of time. So I'm going to go ahead and end the video there. Hopefully this helps. This is our last lesson of the chapter.